Back when I was earning my master's in meteorology under the Fire Weather Research Laboratory, we would do something that you could almost describe as fire chasing. We would figure out when a big fire was popping up in California, and we would drive two of our trucks there. They're these big F-350s, and one of them had a radar on the back of the truck, and the other one had a LiDAR on the back of the truck. Now, if you don't exactly know what those do, doesn't totally matter. All you need to know is that we were driving up to these fires and pointing these weather devices at the plume and taking observations around the area so that we could get an idea of what the fire weather was like around this fire. And then what we could do is plug those observations into a model and then be able to predict how the fire was going to move in the future. So that's one of the advantages to knowing more about fire weather. And I'm about to start chapter 3 of Fire in California's Ecosystems. So I thought I would just do a quick introduction to fire weather principles, going over the main 3 factors: temperature, wind, humidity. Then you also have other important things like stability, or obviously precipitation. And then you also have the fact that wildfires can even create their own weather, and in some cases form what you call pyrocumulonimbus clouds, which is basically when a wildfire creates its own thunderstorm. One of the, I'd say, wildest words in the meteorology and wildfire dictionary, pyrocumulonimbus. So first we'll just go into the big 3: temperature, wind, humidity. And we'll start off with temperature and humidity because those are kind of coupled together. You could think of temperature's direct impact on wildfire is going to be through humidity. As things warm up, the air can hold more water vapor, so your relative humidity is going to go down. That's basically a fancy way of saying it's going to get drier out there. And then the reason that's important is because if your air is dry, your fuels are going to get drier. And then if your fuels get drier, it's either easier for a fire to start, or if you already have a fire, it's going to be a lot easier for that fire to spread. Now, the reason for that is when a flame is, let's say, moving up to a new bush that it wants to combust. I don't know if it really wants to, but that's what the fire is going to do. Before that bush catches on fire, the water within that bush needs to evaporate. Now, how that happens is some of the energy from the fire goes into evaporating that moisture before the bush becomes flammable and combusts. So if that bush is already very dry, the fire doesn't need to use any of its energy to evaporate the moisture out of it. It can just come up and then the bush just bursts into flames. So that's why when the air is dry, your fuels are going to get drier, and then that's going to lead to more active and extreme fire behavior. Now, there's a bit more nuance even within that, and this kind of goes more into fuels than fire weather, but it is an important thing to touch on, is you have different categories of fuels. You have what you call 1-hour fuels, 10-hour fuels, 100-hour fuels, 1,000-hour fuels. For 1-hour fuels, you could think of very fine or very small, like leaf litter or needles, something very small that's going to be able to change its moisture within an hour to kind of accommodating for the moisture in the environment around it. So that's going to be your very fine fuels. And then 100-hour fuels, you could think of something about the size of your wrist. And then 1,000-hour fuels, that might be a full-on branch, or when you get up into like the size of trees. And those are going to respond to moisture much slower. So there's almost a delay in terms of how dry the air is and how it affects your fuels the larger the fuels get. So that might be going a little bit into the weeds. So we'll just come back to temperature, relative humidity. The main thing you need to know there is that there's a cycle. If you've lived on Earth, you pretty much know this. At nighttime, it gets cooler. And then because your air is cooling down, it can't hold as much moisture. So then your relative humidity goes up. So a lot of times your fire activity is going to decrease in intensity overnight because there's a lot more moisture in the air, a lot more moisture in your fine fuels, so the fire's not spreading as fast. The peak of your fire activity is typically going to be between maybe 12 in the afternoon to 4 in the afternoon. That's when your warmest temperatures are going to be. And then there might even be a little delay after that when you still have some warm, dry conditions and when you still have the afternoon winds going on into the early evening. So as you get into the afternoon, temperatures heat up and then relative humidity drops down, and that's going to lead to more active fire behavior. Now, I just mentioned winds. That's another big factor. And that's a factor for a number of reasons. First thing you could do is just think about a campfire. Actually, the other day, I did a bonfire at the beach, and getting the fire started was a little bit difficult because it was so windy out that my lighter kept going out. But once I got it started, the campfire was roaring. It was almost a bit much. It was throwing some sparks on our blankets and to some of our backpacks. And the reason for that is because it was very windy conditions and it was providing a lot of oxygen to the fire. And oxygen is one of the things a fire needs to survive. It needs heat, oxygen, and fuel. So if wind is supplying more oxygen, that fire is going to be more active. And then I also kind of gave a little hint as to another impact that winds have. When I mentioned that I was picking up maybe little sparks or embers and it was throwing it on our blankets, right when that happened, we would kind of pat it down so that the blanket didn't catch on fire. Because if we didn't do that, then you could get what's called a spot fire. And this is what happens on wildfires, and I've seen the importance of this. I believe it was the Dixie fire I was forecasting for. They had done a firing operation around the entire northern side of the fire. So they burned out a lot of the fuel so that when the fire bumped into that wall of burnt fuel, then there wouldn't be any more fuel, and then the fire would hopefully stop in its tracks. But what ended up happening was it was such a windy day, it picked up burning embers, threw it over that protective barrier they'd created, and then the fire took off 15 miles in one day because of those spot fires that were able to go over their fuel break. So it provides more oxygen, it can lead to spot fires, but then it also just pushes the flames forward. You can think of the heat from a fire. If it's very calm, a lot of that heat's going to be going straight up. But if it's very windy, some of that heat's going to be radiated in front of the fire, and that's going to help dry out the fuels before the fire even gets there. So then that also helps reduce the moisture in the fuels, along with if it's in the peak of the afternoon, it's very hot and dry out, and then that's going to help the fire move faster. And it also tilts the flames over, and then that's also going to dry out the fuels more and get them ready to combust. Because think, if you have your flame going straight up and you have a tree right here, a lot of that heat is just going straight up, but if the winds are tilting that flame over, now it's getting a bit closer to that tree and it's able to, the heat from the fire is able to evaporate some of the moisture out. So that's the main reasons or the main dynamics that the winds bring. But it also matters what direction your winds are coming from. This is especially true for California. If you have an onshore wind, that can actually be a good thing for your fire, especially if it's along the coast, because that could take some moist conditions you have over the ocean, and then it can push some moisture over your fire, which would be good news. Now, where wind direction is bad in California is typically when we have offshore wind events or downslope wind events. So this is going to be called the Diablo winds in Northern California, the Santa Ana winds in Southern California, and then the Sundowners in Santa Barbara. It's where you have offshore winds, and the reason that's not good for fire is because if it's an offshore wind, that means it's originating over land, and that's going to be drier than an onshore wind that's maybe originating over the ocean. So it's pushing in very warm, dry air. So then you not only have all the factors where your wind increases fire behavior, but then it's also bringing in warmer, drier conditions. So that's where we usually start to worry a bit more as we get into fall in California. The offshore wind events are great for surfers out there. We all love it. But in terms of fire, that can create the opportunity for some extreme fire weather days. So I think that pretty much sums up the main things you need to know about temperature, wind, humidity. Another one that's maybe important is the effects that smoke has, because that actually kind of ties into wind. So if your winds are very calm, your smoke is going to be settling over the fire a bit more, and this can actually be a good thing, where it's almost like a negative feedback loop for your fire, where if your fire creates a bunch of smoke, and then maybe overnight it's very calm, so that smoke just settles down, then that's almost like clouds, you could think of it that way. So you're going to have less sunlight coming through the next afternoon. That's going to lead to less daytime heating, so then you're going to have a bit more moisture, and then you don't have big pressure differences building up, so maybe your winds are going to decrease as well. Maybe your canyons or hillsides aren't going to heat up at different speeds, so you don't have pressure differences there. So then you don't have upslope or up canyon winds. So if you have a calm night into a calm morning, or you have a strong inversion or a very stable atmosphere and you have the smoke just settling over, that can really calm things down. And I've seen that happen before where I'm forecasting and I look at the forecast and I'm like, ooh, tomorrow is going to be 85 degrees, 11% relative humidity, and we're supposed to have 30 mile per hour wind gusts in the afternoon. We can expect a very active fire day. And then I look at the live cams the next morning and the entire fire is just socked in with smoke and the fire is barely doing anything. And then it ends up being 75 degrees with 20% relative humidity and 12 mile per hour winds because the smoke was settling. Now then things can start to change. If your winds pick up, it disperses the smoke out, which can improve your air quality, which is sometimes nice, but then it can also lead to much more active fire behavior because you start to get more sunlight in, heats up, it gets drier, it gets windier, and then more smoke is being produced. So yeah, two sides to every coin in that regard. So that's some of the impacts that smoke can have. Now we could talk about thunderstorm activity. This is a bit of a wild card when it comes to wildfire in California. You would think thunderstorms could be beneficial because it brings some rainfall, but usually the thunderstorms move so quickly and they don't last that long, so it doesn't bring enough rainfall to really soak up your soils and lead to increased soil moisture, which leads to increased fuel moisture. So usually thunderstorms lead to worse wildfire conditions where you can have some gusty outflow winds, which can be a bit erratic. You don't really know which direction they're going to be moving in. So then that can lead to erratic fire behavior. And then the obvious one, if you have thunderstorms, you can have lightning, and then that can start new ignitions. And that's definitely something we've seen be important in California. Like in 2020, we had all the moisture funneling in from Tropical Storm Fausto, so we had a bunch of thunderstorms all over the state, and it started hundreds of lightning fires and overwhelmed our resources just because there were so many fires at the same time. And then we ended up having arguably the worst wildfire year that we have had in recent memory. Now, the one that I briefly touched on in terms of thunderstorms was precipitation, but then you can also just think of precipitation on kind of a more climate scale, where in California we pick up a lot of our rain in winter, and then it's going to be dry throughout much of summer and then into early fall. So that's why our wildfire season is as bad as it is in California, because our warmest, driest part of the year coincides. So when it's hot, it's also dry, and then in fall you start adding in some of those offshore winds. But how much rainfall you pick up is going to have a big impact on wildfire behavior, because like this last winter, we picked up like 2 to even 3 times as much rain as a normal year from the central California down into Southern California. And it's been a pretty calm wildfire year. Normally at this point in time, we would have burnt 1 million acres. We burnt only 250,000 acres because there's just been so much moisture in our fuels. There was a lot of snow in the Sierra that slowly melted into the early summer. You could say snowpack is another important one. More snow you have, the more snow melt you're going to get, and the more moisture is going to slowly release into your fuels. But that's certainly helped us out, and that's a big part of the reason that 2023, knock on wood, hasn't been a bad wildfire year yet. But then you think to this last decade in California, where we had long periods of drought, big part of the reason that we had such bad wildfire conditions. If you don't have as much rain, your fuels are going to be a lot drier, and then it's much easier for fires to start and spread once they do start. So I think that's probably a decent enough introduction to fire weather principles. You've got lots of different things going on. You've got temperature, wind, humidity, rainfall, thunderstorms, smoke, stability, and I'm sure I'm going to be learning a lot more about all of this in Chapter 3 of Fire in California's Ecosystem. So if you want to learn more as well, you can stay tuned, and thanks for watching.